It began like any other interstellar sighting. A fast object on a clear night, logged by observatories around the world and catalogued as 3I Atlas. But something about this one felt different. It wasn't just the speed, nearly 60 kilometers per second, fast enough to escape the sun forever, and it wasn't only the size. With a nucleus estimated between 3 and 7 meters across, it was one of the largest interstellar objects we'd tracked. What cracked our certainty was subtler: the trajectory didn't fit. At first glance, orbital motion should be straightforward. Gravity dominates. Radiation pressure and gas outgassing add complications, but they leave traces. This time, when modelers plotted 3I Atlas's path against reality, the math refused to match the sky. The residuals, those tiny gaps between predicted and observed positions, weren't random noise. They were systematic, always biased the same way, growing steadily over time. Multiple observatories confirmed it. This wasn't a data glitch. Something invisible was nudging the object, and the force involved didn't comport with known natural mechanisms. When the James Webb Space Telescope turned its powerful eye toward 3I Atlas, astronomers hoped for answers. Webb revealed an uncanny chemistry. The object's coma showed a carbon dioxide to water ratio near 8:1, the reverse of what we expect from comets. Nickel lines spiked. Iron was curiously absent. Dust loss was measurable but not extreme. The jets and vents were active, but nowhere near powerful enough to alter the trajectory of a body of that estimated mass. In short, it was erupting, but not explosively, and not enough to explain the steady, precise push it was experiencing. The memory of 2017 returned. Oumuamua had accelerated in a way we could not fully explain. Back then, hypotheses ranged from hydrogen outgassing to radiation pressure to structural oddities. None fit perfectly. Now, with 3I Atlas, the same signature repeats, but on a scale that leaves no room for comfortable doubt. If Oumuamua's anomaly could be dismissed as an oddity, 3I Atlas forces a different question. What if this is a pattern? To move a massive object in interstellar space requires force, sustained, directional, and precise. Chemical propulsion is meaningless at that range. Solar pressure is tiny. Detectable nuclear or chemical exhaust would betray itself. Yet 3I Atlas adjusted course with no thermal trail, no radio beacon, no obvious emissions. It moved like a phantom craft. No signatures, only results. Some scientists propose exotic natural mechanisms, unusual plasma interactions, magnetic reconnection effects, or unknown interactions with interstellar medium structures. Others ask a more charged question: could this be technology? Not in the sensational way of flying saucers, but in the quieter sense of an engineered object. A relic, a probe, a device built to move subtly and deliberately to avoid attention. As the anomaly persisted, orbital teams changed how they looked at the data. Residual isolation techniques were used to separate unexplained shifts from standard gravitational modeling. Language and internal reports grew cautious. Papers used terms like non-conforming motion and unresolved trajectory deviation. The professional discomfort was telling. When measurements are clean and the math fails, the problem isn't the instruments, it's the model. Then came conjunction. As 3I Atlas slid behind the sun, observations went silent, not from lack of interest but from geometry. That blackout, brief and expected, coincided with another subtle change. When the object re-emerged days later, its outbound path had flattened. The new trajectory did not send it straight back into interstellar space as expected. Instead, it had the hallmarks of a long, extended ellipse, a kind of parking orbit that would keep it lingering in the inner system longer than a typical hyperbolic passerby. That change was chilling. Natural passers-by sweep in and out. They don't hang around. Yet after conjunction, 3I Atlas's motion suggested not an escape but a choice to remain in the neighborhood. Not on a collision course, but close enough to make a difference. If this were deliberate, the implication flipped from curiosity to intent. Engineers noted another detail: rotational stability. Where comets usually tumble, 3I Atlas's rotation smoothed. Its axis stabilized across repeated observations. That coherence could be explained by internal mass redistribution or gyroscopic control, structures consistent with purposeful steering rather than random outgassing. Again, no thermal signature, no radio chatter, but motion that looks coordinated. History matters. When astronomers traced the trajectories of interstellar visitors, Oumuamua, Borisov, and other curious transients, a pattern emerged on a galactic coordinate map. Their entry vectors and times hinted at structure, angles and separations that resembled a survey pattern more than a scatter of random wanderers. It was as if nodes of a larger network were sampling our solar system along pre-assigned routes. Patterns that, over decades, avoid one another, optimize coverage, and minimize interference, behaviors unlikely to arise from chance. Closer to Earth, weak but repeatable correlations appeared between 3I Atlas's passes and subtle ionospheric perturbations, small magnetic flutter recorded by high-altitude sensors, and faint radar residuals. These signatures were never strong enough to be alarming on their own, but they reproduced features seen during Oumuamua's transit. Once dismissed as solar or instrumental noise, they now look eerily coordinated, not weaponized, but methodical, like background scans in a survey. In the lab and at observatories, the mood shifted from curiosity to careful unease. Some teams started looking backward through archival data and found faint traces, barely visible signatures of prior visits that had been lost in noise by design or accident. The object's reflective properties seemed tuned to blend into the background light. Its thermal emission sat just below confident detection thresholds. In short, it behaved as if it had been made to hide, to be invisible until it chose otherwise. Could the motion itself be communication? A controlled orbital nudge that reads as a signal to those who know how to look, a mathematical whisper, a deliberate misalignment that forces observers to notice and ask. If a survey system were measuring our response time, curiosity, and methods, then 3I Atlas becomes not just an object but an experiment, a mirror testing how an emerging technological species reacts when nudged out of complacency. The more the data accumulated, the harder it was to keep interpretations in strictly natural terms. Not because science leapt to fantasy, but because the simplest explanations were exhausted. The remaining possibilities were extraordinary, exotic physics that stretch current models or artifacts of something purposeful. Either outcome demands humility. Either we've stumbled onto unknown dynamics of the cosmos, or we've found evidence that something is monitoring planetary systems, quietly and patiently. For the public the image is cinematic: visitors, relics, alien probes. For the scientific community it is quieter and harder to process, a set of anomalies that line up across instruments, times, and missions. Patterns that nudge at the boundaries between nature and design. What matters now is rigorous follow-up. Surveys like the Vera C. Rubin Observatory will soon flood us with detections and force us to refine our filters. JPL and other centers will continue to model 3I Atlas's motion with ever more sophisticated physics. Spectroscopists will re-examine its composition, and radio arrays will listen for the faintest deliberate transmissions. Above all, astronomers will treat the data without bias, testing natural hypotheses to exhaustion before considering design, and examining design hypotheses with strict, falsifiable tests. If 3I Atlas is a natural phenomenon, then we have a new process of the cosmos to learn, one that will reshape models of small body dynamics, interstellar chemistry, and the behavior of matter in sparse regions. If it is engineered, then we have to reckon with an entirely different scale of reality. That a silent, patient architecture exists in space and that we are now one of its measured variables. Either way, this moment matters. It's a test of our tools, our discipline, and our humility. Wave's discovery will keep watching, summarizing, and explaining what the science reveals next. Because whether we are reading a new page of physics or the faint signature of distant intention, the consequences ripple outward, touching philosophy, history, and the simple human question we've always asked when we look up: are we alone? If this changed how you think about the sky, share the video and subscribe to Wave's Discovery. Keep your notifications on, because this is the kind of story that evolves one observation at a time, and you'll want to be here for every new piece of the puzzle.